In this video, we're going to look at units of measurement. So to talk about the units of measurement, first we're going to look at the difference between mass and weight. And a lot of times people will think they are the same thing. So mass is the measure of how much matter you have within a sample. The unit that we most often use in a chemistry lab for mass is the gram, and it has the symbol lowercase g. And this is going to be measured on a balance. Now, weight is similar to mass, but it takes into account the pull of gravity on matter. So, what that means is my mass that I have is never going to change. It is going to be constant. However, my weight can vary depending on the gravitational pull of the area that I'm at. So, if I'm on the moon, I'm going to have a different weight than if I'm on Earth. Is my mass going to change? Nope. The amount of matter I have is still going to be the same. However, the pull gravity has is going to be different. Now, weight in the United States, we use pounds with the symbol LB. Now, weight is not constant. It is going to depend on the strength of gravity. Where it is being measured. So when you are getting the weight of something, you need to make sure that you are consistently at the same place if you're doing this for a scientific purpose. So in your lab, if you're getting the weight of something, you want to make sure you use the same scale every single time in the same area, so you don't introduce unnecessary error. Now, all of these are measurements. Both mass and weight are measurements. Now, measurements always include units. And units are the little symbols that come after a number. So here are some common measurements. We have mass, volume, distance, and time. And here are some common units for those substances. So for mass, we have grams with the abbreviation little g, like we saw above. Volume, the amount of space something takes up, is going to be measured in liters, and the abbreviation is L. Now, keep in mind, this is just one option that you can get these measurements in. There are a lot of different ways you can measure volume. Liters is just one example. Distance, we can use meters, which is given the symbol lowercase m. Now, when we're dealing with science, it's so important that we are clear in our communication. So just like we learned with the atomic symbols, if a letter needs to be capitalized, make sure it's capitalized. If it doesn't, then make sure it is not. And then finally, we have time. It can be measured in seconds, and the unit is lowercase s. The standard units are used to measure experimental variables to facilitate communication between scientists. And so These might look new to you, and that's because they are based off the metric system. And since scientists have to communicate all over the world, we want to use a system that is used by a lot of different places. So this this is a table of the common metric prefixes. What is great about the metric system here is that the units of measurements can be modified by powers of 10. And that makes it a lot easier to deal with the math. So for example, if I look at the prefix milli right here, and I look at this meaning, I can quickly identify how many milliliters are in a liter. That is something that is quick and easy to do. There are 1,000 milliliters in a liter, or we can say there is 0.001 liters in 1 milliliter. With our system that we use in the United States, it's much more difficult. It's very rare that you find someone that can quickly tell you how many teaspoons are in a gallon. That's just not something that we know. And so the metric system is so nice because it is a base 10 system. Furthermore, we use this system for any types of measurements. So to measure the mass, volume, or distance, you can use these prefixes to describe those measurements. And so if we were doing distance instead of volume, I could say there are 1,000 millimeters in 1 meter. So prefixes are modifiers that can be used to convey larger or smaller quantities in a clear and concise manner. Again, like I said, I can easily say there are 1,000 milliliters in a liter. Or I can say there are 1 million microliters in a liter. I can say there are 1 million micrograms in a gram. That is very clear. It is concise because I can do it very quickly if I know the metric system. Now, when you are using the metric system, it is very important that you are careful with the meaning of the prefix. So let's look at an example of what I mean by that. On this previous table, I can look up the prefix mega. It has a symbol, capital M, and this is the meaning of the mega. It's the decimal equivalent. So this isn't how many megagrams are in a gram. This is how many grams are in a megagram. So these decimal equivalents always go with the base unit. All right, so let's look at the base units first. We'll establish the base units. So for mass, the base units are gram, and that has the symbol lowercase g. For volume, the base unit is a liter, and that is given the symbol uppercase L. And then finally, distance has a base unit of meters, and that is given the symbol lowercase m. So if I wanted to look at the relationship between grams and micrograms or grams and megagrams, I can look at this table here. Mega, the meaning or the decimal equivalent is 1 million or 10 to the 6. Micro is this number here, or 10 to the negative 6. So if I wanted to look at the prefix megagrams and the prefix micrograms and compare them to grams, I would put the meaning or the decimal equivalent for the base unit. So my base unit in this case is mega. And on the previous slide, I already saw that mega meant 1 million or 10 to the 6. So I can write 10 to the 6, and that is going to go with my base unit, and that is equal to 1 megagram. Now, if I wanted to do microgram, then I can look at my previous slide again. Micro is 10 to the negative 6 or 0.000001. Hopefully I put enough zeros in there and I didn't add any extra. So when I write that out, I can write it as 10 to the negative 6 grams. Remember, the decimal equivalent always goes with the base unit, is equal to 1 microgram. Now, what's so cool about the metric system is I can do that with the volume. If I have a megaliter, then I can use the exact same equality, except the only thing that is going to change is my base unit because we're dealing with liters instead of grams. So I have 10 to the 6 liters is equal to 1 megaliter. If I wanted to do microliters, then I would do the exact same thing again. I still would use my 10 to the negative 6, but now I would apply that to the base unit liters, and that would be equal to 1 microliter. Man, I really want to make those grams. There we go.